Recently, I have been experimenting with simple robots that have moderate degree of controllability. I came up with this design consisting of 4 piezo buzzers, which are combined into 2 engines. 2 engines are connected at right angles, and each engine consists of 2 piezo buzzers, also connected at right angles. A leg is attached to piezo buzzers, also at right angle. Allows you to move this leg in different directions. As material for the robot, I choose copper wire, following the Gann-Gilbert principle of the hierarchy of dimensions. The easiest and cheapest thing is to make it of wire or sticks. If you cannot make it of wire, you are starting using sheet material. If you cannot make it of sheet material, you are making it of solid material. Of course, you need a certain number of calculations, a certain number of templates and jigs, and voila, we have the basis for the robot. Piezo buzzers are attached with hot melt glue. I do not hope that it provides isolation, so that all the buzzers have common ground. After attaching piezo buzzers and some fuzz with templates and prototypes, I make a brass foot. Good sanding and degreasing are essential, as I expect a severe challenge to the glue here. I also attach a piece of bamboo to increase friction. I use 2-component polyurethane adhesive due to its suitable combination of toughness and hardness. To increase the likelihood that the actuator will work, I will fit it with the maximum allowed voltage. Also, I expect that the device will be noisy, and to make it as least noisy as possible, I will power it not with rectangular, but with smooth voltage. For this, I need to develop an amplifier filter. The maximum voltage for the piezo buzzer is 30 volts, and the resonance frequency is 3 kHz. And for this amplifier, I choose the OPA 604 op-amp. As a signal source, I will take Raspberry Pi and generate voltages with DMA. Therefore, given that supply voltage is 3.3 volts, the amplitude will be 1.65 volts, and for the output voltage 20 volts, the gain will be 22 decibels. To design the filter, I will use the first available tool for analog devices, low-pass filter, gain 22 dB, bandwidth 5 kHz, the ripple in the pass band we do not care. Let's see the gain in another view, and see a hump on 3 kHz, which is generally even good. Trying 24 volts power. Analog devices cannot offer anything. We select 18 volts and optimization for the voltage range. Now we recalculate everything with rough values. We look at the result of the scatter simulation. For the prototype is good enough. The software for generating impulses is written in Python using PyGPIO library. Basically, it follows the example for the function generic at waveform. filling lists, cleaning the waveform and filling it with necessary transitions. In the motors class, the set function calculates transitions. Then the transitions are combined into masks up and masks down. A bit equal to 1 in the mask up means that in this transition the GPIO with the number equal to the bit position will be set to 1, and in the mask down set to 0. The test code has one fixed phase and two variable phases. The engine has 4 piezo buzzers, and the absolute value of the phase doesn't matter. Therefore, one of the phases is taken as the point of reference. And we have 3 variables for control. Run this code, and what do we see? We see the waveforms from the output of the amplifier, changing phases, the contraption itself doesn't really move. I think I just found a way that won't work.